Okay, number 1 has Eve can choose from the following notebooks. Lined pages come in red, green, blue, and purple. Graph paper comes in orange and black. How many different color variations can Eve choose if she needs 1 lined notebook and 1 graph paper? Why can we use fundamental counting principle? You're using it, but why can we? Because she's choosing 1 of each, right? Remember I told you if she chooses more than 1 of each, you won't be able to use this. So you have to keep that in mind because that will happen later, okay? So the reason why we can use fundamental counting principle is she is choosing 1 lined notebook and 1 with graph paper. So we're going to get lined, which is 4, and graph, which is 2. And the answer for you to add them is there, right? Which would be wrong because we have to multiply because we need lined and graph, right? Which means we multiply because of the and. Okay. Number 2. So that's right, that's B. Number 2, a combination lock opens with the correct 3-digit code. Each wheel rotates through 1 to 8. How many different codes are possible? So 1 to 8 for each one, right? So how many for each? 8. Which is the same as 8 cubed, which is 512. A combination lock opens the correct 3-digit code. Each wheel rotates the digits 1 to 8. Suppose each digit can be used once in a code. How many different codes are possible when repetition is not allowed? So we'd have 1 to 8, which is 8, and when we have repetition not allowed, we box it. So we get 1 to 7. So 7, and then we get 1 to 6, which is 6. 8 times 7 times 6 is 336. A restaurant offers 60 flavors of wings. How many ways can 2 people order 2 different flavors? So how many blanks are we going to have? 2. This one has 60, and this one has
59.
And you multiply because they're having both. So which one is that?
3,500.
Okay. You think that's going to be the loud problem in this class? That big? I question your judgment on that. 5. The lunch special at a sandwich bar offers you a choice of 6 sandwiches, 4 salads, 6 drinks, 3 desserts. How many different meals are possible if you choose 1 of each? So here's that 1 of each thing again. So we can use the fundamental counting principle because we're taking 1. So we're going to have 6 sandwiches times 4 salads times 6 drinks times 3 desserts, which is
432.
combination lock opens with a 4-letter code. Each wheel rotates to the letters A to L. Does it say anything about not repeating? No. How many letters are A to L?
12.
12. So we're going to go 12. 12 to the 4, which is
20,736.
7. A combination lock opens the 4-letter code. Each wheel rotates the letters A to L. Suppose each letter can be used only once in a code. How many different codes are possible when repetition is not allowed? So now we're going to have 12, and then we're going to hold 1, right? Then we have 11, 10, 9. Is it A, B, C, or D?
B.
Okay, this is one of those letter tile situations. So sometimes we use all of the letters, sometimes we only use parts of the letters, right? So we have to read thoroughly. It says, suppose a word is a string, any string of letters. How many 3-letter words, so 3 of them, can you make from the letters in Regina? Does Regina have any doubling or tripling letters? No. How many letters is there? 6. And now I put it, you do not repeat any letters in the word. That's me being nice. They won't say that, right? Because you know you have the word Regina. So 1, 2, 3. I have all 6 for this one, and then I hold 1. 5, hold 1, 4, which is D. Suppose a word is any string of letters. How many 5-letter words can come from Kelowna? Kelowna has 7, and none of them are doubling or tripling, right? We're going to make 5-letter words. 1, 2, 3, 4, 5. And it has 7. So we have 7 times 6 times 5 times 4 times 3, which is?
2,520.
Then number 10. Number 10 says, how many numbers are there from 1,000 to 1,999 that do not have repeated digits? So we go and put our 4 blanks. We know that this one has to be a 1. Right? It's the only way it's going to work. Then it says do not have repeated digits. So I am going to box it. So I've used up the 1. Now I have 2 to 9 plus 0. So how many is that? 9. Box the 0. You get 2 to 9, which is 8. Box the 9, let's say. 2 to 8, which is, I went to write 8. It's not 8, it's 7. 9 times 8 times 7?
504.
Oh, she won. In this speech. Okay.
No, you have to be almost half.
At least almost. Yeah. How many ways can you rearrange the word pokey if the first and last letters must be consonants? What's a consonant?
Not a vowel.
Not a vowel. Consonant. So, 1, 2, 3, 4, 5. How many are there? P, C, K. So that's 3. Hold one of them. P, C. 2. Hold the C. Then I would have O, E, and P back, which is 3. Hold 1. O, E. 2. Hold 1. O. 1. So it's 6 times 6, which is 36. Okay, how many odd 3-digit numbers are there if it can be repeated or cannot be repeated? Okay? So, can be repeated. In order for it to be odd, it needs to end in 1, 3, 5, 7, 9, which is 5. I don't box any because it can repeat, right? So it doesn't matter what I left there. Then I have 1 to 9 because I can't start with a 0, so that's 9. And then I have 0 to 9, which is 10, which is 450. And then cannot be repeated. Same thing, but I box them. So 1, 3, 5, 7, 9. Box the 9. I have 5. And here I would have 1 to 8, which is 8. And then here I would have, say, box the 8. 1 to 7. And people want to put 7, but we have to bring back the 0. So it's actually an 8. So you remember to bring that 0 back, right? What's 8 times 8 times 5? 64 times 5.
320.
Okay? And that is it for that. So we're going to go back to our notes where we ended up.
Come around and get
So this next one, a lot of people read into it a little bit wrong. With the new renovations completed at Holy Trinity Academy, there will be 7 entrances. In how many, this is not true, in how many ways, different ways can a student come in for math tutorials if they enter and exit through any entrance? So I'm entering and I'm exiting. That's 2 blanks. That's all you should have. An entering blank and an exiting blank. So you're in like good a good community, because I'm pretty sure everyone doesn't put 2 blanks. So, you did, yay. If you didn't, eh. So, we have 7 entrances to enter in, and then it says through any exit we can exit. So it's just 7 times 7, 49. Then we have to enter the school and exit through a different entrance, right? So when we enter, we still have how many options? 7. But we have to exit through a different entrance. So how many do we have to exit? 6. So 42. Now we have to enter and exit through the same entrance. So we have to enter and exit through the same entrance. So when we enter, how many options do we have? 7. Now we have to exit where we entered. So 1.
Is that following the arrows or not following?
This is before the arrows. Okay.
Do you think the whole year will be arrows?
3. The score at the end of the second period of the hockey game is 6-3. Remember that this is me being nice. They would never do that. Remember, games start at the score 0-0. Matthew Kachuk was trying to determine how many, on the side during the break. He was trying to determine how many different possibilities there are for the score at the end of the first period, right? It's just like, just sitting there. I wonder what it could have been. I don't know. Yes. Smart. Engineer, really. He used the fundamental counting principle and multiplied 6 by 3, which was problematic for the guy. And he got 18, which is an error, because what should it be? That is, you guys are all with Kachuk.
Well, I don't think that you should have used 6 and 3.
Why not?
What should you have used?
Hold up. I might just be missing something. What is he trying to, he's determining through the
How many options the first period could have had?
Oh.
Wait, is the game over or is it still in the first period?
This is the end of the first period.
Oh,
And then the
He's
second
just-
period. Well,
end
it's
of
the end of the second period.
Sorry, end of the second period, and he's deciding at the end of the first period what his score could have been. So in the second period, they could have scored nothing, right? And it'd still be 6-3.
Right.
In the first 5 minutes of the game, they could have scored all of them, and it would have been 6-3. Or in the second period, you could have scored all of them, 6-3. It's not going to happen, but they could. Why is it wrong? Because you guys are going to go Flames 6, right? But it's not 1-6. What's the score could have been? Could have been 0-6, which is actually
7.
And the Oilers,
0, 3, 0.
So I was onto something.
you were onto something, yeah.
I just didn't know what I was onto.
You just didn't know where to go with it, but you were onto something.
Would have had it if I had my grade. So.
Number 4. If each of the students in a class of 30 students is capable of winning any of the class prizes, how many ways are there of awarding a first and a second and a third? So if you win first, you can't win second and third. So I have 30 to win first, right? Then to win second, 29. And then to win third, 28. How much does that equal?
24,360.
Then we have a math prize, a chemistry prize, and a physics prize. You have to remember there could be a genius amongst you. Okay? Could the genius, if they win the math prize, not be allowed to win the chemistry prize? No, they totally could, right? And they could win the physics prize. So, 30 times 30 times 30, which I believe is 27,000.
Yeah. Okay.
Flipping over.
Oh, wait.
3-digit numbers are formed using only the digits 2, 3, 5, 6, 7, and 9. If repetitions are not permitted, how many 3-digit numbers can be formed? So I have 1, 2, 3, 4, 5, 6 for the first blank, right? And it says repetitions cannot be used, right? And they're not permitted. So what would the next one be?
5.
5, and the next one be
4.
4, which is
120.
120. Then we have less than 400. If it's less than 400, the first blank has to start with a 3 or a 2. And repetition is still not permitted. So that's 2 options, right? Yeah,
No, why is repetition not?
because it's set up here.
I'll answer the whole question.
Yeah. So we hold it. And then we have 2, 5, 6, 7, 9. So I have 5. Because I can have any number after that if it starts with a 2 or a 3. It will be under 400, right? And then I'm going to have 4. So it's 40. Evens. It's going to have to end in an even. Now, when you would ask would it be half, it would be if you were 0 to 9, right? But when it's like this, it doesn't guarantee half. So in order for it to be even, it has to end in an even number, right? So our only even options are 2 and 6. So that's 2. Then we hold 1. And now we would have, we don't have to worry about the 0 coming back because it didn't even give you a 0 option, right? So now we would have 2, 3, 5, 7, 9, which is 5. Let's say I hold the 9, and I would have 4. So it's 40. Then odds, I have 3, 5, 7, 9. So I have 4. If I hold the 9, then I would have 2, 3, 5, 7, which is, and 2, 3, 5, 6, 7. So I would have 5. Hold a 2, so I would have 4, which is 80, which makes sense, right? Because if you're using what Kyle was saying, if the total of 3 digits, no matter what, can be formed as 120, if I take away all the evens, I would be left with the odds, right? So we could have gotten 80 just even having found that we had 40 evens. Because they should add up to 120, so we had the 120. Multiples of 5 means they have to end in a 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 are multiples of 5. So they could end in a 5 technically, or they could end in a 0. The reason why I didn't mention the 0 is there's no 0. So it has to end in a 5 in this case, which is one way. Used it up. Then we have 2, 3, 6, 7, 9, which is 5 options. Then we have 2, 3, 6, 7. Which is 20. We can do 6, 7, and 8, and 9. So work on those. I'll give you about 5 to 10, depending on how good you work. And we're moving on to factorial. Okay, we're going to go through number 6. Determine the number of 4-letter words that can be made. So we need 4-letter from shipwreck. Each letter must be used once. And it doesn't say that you can't repeat, right? But it's a word, so we know that they can't, correct? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters, and none of them double or triple, right? So we're going to go 9 times 8 times 7 times 6. And what do we get?
That's
3,000, pardon?
24.
We agree? Okay. Contain only consonants. How many of them are consonants? S, H, P, W, R. Yeah. So we have 7, then 6, then 5. Because we have to go down in a number because we're holding one.
It's a 4-letter word.
and then there's a 4. Why do I want it to be a 3-letter word? I just did. How much is that?
800.
Begin and end with a consonant. So you have to begin with a consonant, which is 7, end in a consonant, which is 6. Then is there any stipulation on those middle ones? Cody, go ahead. Right. So we need to have the 2 letters in the middle, right? So we've used up 2. So how many do we have left for the middle? 7 and 6. So how much is it? 1764? Okay, begins with a vowel. How many vowels are there? 2. Then I leave one there. How many letters do I have left for here? 8, then 7, then 6. So how much is that? Begins with a D. How many D's are there? None. Do I care about the rest? So it's going to equal 0. Because we could go 0, then 8, 7, 6, or 9, 7, 6 technically. 9. So it'd be 0. Contains the letter P. This is like that other one. So we can start with a P, which is 1, and then we have 8, 7, 6, right? And then that P is going to move how many times? 1. It could be here. 2 could be here. 3 could be here. 4, right? So we just multiply by 4. Or you can show it in the first blank, and then a case in the second blank, and then a case in the third, and then a case in the fourth, right? And you'd still get the same thing. So what's 8 times 7 times 6?
1,344.
Times 4?
Hold on.
That's times 4?
336 is the
336. Yeah.
336 times 4, which is?
1,344.
Perfect. All right, number 7. How many different 3-digit numerals can be formed from the digits 1, 5, and 8 if they can't be repeated? So you'll have 3 here, 2, 1, which is 6. The next one says, how many different 3-digit numerals can be formed from 1, 3, 5, 7, and 9 if the digits may be repeated? So you have 3-digit numerals. So it's going to be 5, 5, 5, which is 125. How many 4-digit numerals can be formed from the digits 0, 2, 3 if the digits may be repeated? How many options do I have for here? 2, just the 2 and the 3, right? And then 0, 2, 3, 0, 2, 3, 0, 2, 3, right? So 54. And then how many different non-zero numerals? So basically what that means is you can't have the number 0 and count it. Okay? Non-zero numerals are possible using some or all of the numerals. 0, 1, 2, 3. Digits can't be repeated. So it's saying some of them or all, right? So I can start with a 1-digit number. What could my options be? 1, 2, and 3, which is 3 options, right? I could have a 1-digit number. Or I could have a 2-digit number, which would have 1, 2, 3, box 1. So I have 3 options. And then here I would have 3 options again. 0, 1, 2, 3. Or I could have a 3-digit number, which would be 1, 2, 3 again. Just 3. Hold the 3. 0, 1, 2. 3. Hold the 2. And 0, 1, 2. Or I could have a 4-digit. Could I have a 5? No, because I only have 4. So it'd be 1, 2, 3. And then I have 0, 1, 2. And then I'd have 1, 2. And then I'd have 2. So I would get 6, or 3 plus 9 plus 18 plus 18. So I'd get 36, 45, 48. And the other two we'll do quickly at the beginning of class on, or tomorrow, and then we're doing factorial.